Okay. Today we're doing page 10, exam 1, page 10, section 6. Section 6, number 2. This is a k substitution for f of x on the piecewise function. What this means, let me draw it out. When f of x, we're not using the graph today, we're just going to use it for background, so don't worry about the graph. As I said, a piecewise function. So we're going to have negative 3x plus, minus k. Let me erase that real quick. I don't really like it. Negative 3x minus k when x is greater than 3. And the bottom function is going to be when 2x squared is when x is greater, is less or equal to 3. Okay, so what you want to do first is solve for k. So we're going to solve because both of the functions are approaching negative 3. So they have to kind of equal each other to a point. So we have 2x squared equals negative 3x minus k. It doesn't really matter which one goes first and which one goes second, or it's going to equal to the same thing. Okay, so we're going to add 3x from both sides, which is just going to be algebra. So we get 2x squared plus 3x equals negative k. And we're going to make this k positive by just making the other side negative. X squared minus 3x. And we do this by taking out the negative and just putting it over here. And then this is going to equal k, because a negative times a negative is a positive. And the next, since we know that the function is approaching 3 from both of the graphs, we're going to put in, plug in 3 for x equals k. So this is going to be negative 2, 9 minus 3. This is going to be negative 18 minus 9, because 3 times 3 is 9. If you add both of these together, 9 plus 18 is going to be negative 27. So since that we found k, let me make sure that this is the math we were doing. We're gonna then put it to the piecewise function. So we're just gonna have the piecewise function over here. So negative 3x plus 27, because when you plug in negative 27, the negative in front of it will turn positive, because again, a negative times a negative is positive. We're gonna just do a piecewise function. Let me do f of equals this, and the bottom will be 2x squared. So this is what we found out, and this is going to be the graph when this is going to be the function when x is greater than 3, and this will be the function when x is less or greater, or is less than equal to 3. So let's put this in the limit form to see if it's continuous. This is the first, the question is we're assigned to k, we're given k, and we're going to see if both the functions are continuous at 3, or both the slopes. So the limit as x approaches 3 from the right side, because x is greater than 3, we're going to plug in 3. So negative 3 times 3 plus 27 is -9 plus 27, and this will equal 18. You could use a calculator to determine that. And we're gonna erase this side over here because we already explained it and we're plugging it in now. Okay, we're back. So now we're gonna find the limit when the x approaches 3 from the left side. So this is going to equal 2, 3 squared. This is going to also equal, this is going to be 9. 2 times 9 is 18. And I also forgot to put the limits. So always put down your limits. You don't want your teacher deducting points from you, even when you got the answer. You know, it's just got to discipline yourself. And the limit over here, as x approaches 3. Also reminds you like what you're, doing all this math for. We're trying to see if this is continuous. And we find the continuous as the limits approach the number. So as you could tell, when the left side of the limit of the graph approaches 3, it approaches 18. And over here, we're given that when the limit approaches 3 from the right side, it also equals -18. So what this is doing from the left side is approaching 18. Say this is 18. And the right side is also approaching 18. So that means that it's going to be continuous because both of the ends meet. So, and then we could also put this by putting as the limit approaches 3 f of x, it's going to equal 18. So, yep, it's continuous when x is at 3, given here.